Hello students, this is Mr. Chong once again. Today we'll be looking at activity 3.2 on condensation and boiling. So for the first part, it will be part A and the second part would be part B. So we'll be looking at condensation for part A, at what are some of the things that we need for this experiment. So on the table here, you will notice that I have a beaker of hot water, a cup that is labeled B, a cup that is labeled A, and cold water together with two lids. Now, if you do not have lids, you can also use plastic. Now, the next thing we're going to do, step 1, is to actually pour an equal amount of water into hot water into beaker A and cold water into beaker B. So this is my hot water. I'm going to pour approximately about about 50 ml thereabout, and I will cover it with my plastic lid. I would then do the same for my cup B, but this time around I'm going to fill up with cold water, about 50 ml, and then I'm going to put on my lid again, and then we're going to let it sit for a while, about 10 minutes, and then we're going to see what happens. Hi students, it's been about 10 minutes. Let's take a look at our experiment to see what has happened. So this over here, cup B, is where we have our cold water, and cup A is our warm or hot water. So when we take a look at our lid for cup B, you would see that it's clear, there's nothing. Looking up from the top, there's a stark contrast between the two. So for cup A, you would see that it has frosted up. And if we open it up, you would see that water droplets has actually formed on the lid. So if I will take my hands and I will actually to drag it across, you would see that a clear path has been formed. And this is because the water droplets have been wiped off. So hot water vapor actually rises from the hot water, goes up, touches the cooler surface of the lid, and has condensed on it, forming water droplets. Hi students, we will now look at part B, where we'll be exploring the process of boiling. So right now, I've got the setup that I need, the apparatus. So I have a beaker of room temperature water, thermometer, as well as a metal tray. So the first step of it would actually be to measure the water, alright, before we actually start the experiment. So if we do a close-up of it, you would see that the temperature of the water is approximately 29 degrees Celsius. Alright, so we're going to put this beaker onto the heating tray and let's see what's the temperature like. Okay, so we'll come back to measure it in a while. It's been a while, let's see what's our temperature like. As we can observe right now, the water is still not boiling, so let's go ahead and put our thermometer in to take a look at the temperature. Now do note that when you put your thermometer in, it should not be touching the base of the beaker when you are taking any temperature. So when you look at it, we are roughly at about 35 degrees. Alright, and as you can see, the red line is slowly climbing up to 40. So we know for sure that our water is gaining heat from the heating plate. Alright, so now it has touched 40 already. We'll come back in a while when it starts to boil. Alright students, welcome back. As you can see, bubbles are now forming from the bottom of the beaker all the way up to the surface. This shows and tells me that my water is now boiling. So before I look at the thermometer, can you guess what would be the approximate temperature of the boiling water? So let's take a look. Now looking closely at it, you would have realized that it has reached a 100 degrees Celsius. So if you have guessed 100 degrees Celsius, you are right to say so. So I would like you to predict what would be the temperature after 5 minutes. Will it increase further, decrease, or remain the same? Alright students, it's been 5 minutes. Let's take a look at our boiling water and see what's the temperature. So if we take a look at it, a close look at it, you would have seen that the temperature of it is still at 100 degrees Celsius despite boiling for 5 minutes. This shows us that during the change of state for boiling, temperature remains constant and unchanged until all the liquid water has boiled off to become gaseous water vapor.